Hello and welcome to part 2 of understanding angles. Today we are going to focus on understanding how angles are measured. Last week we focused on classifying angles. So what is an angle? Many times students are often taught about angles with a simple declaration of the definition, such as you see here where two rays with a common endpoint or where two sides of a polygon meet. Today we're going to focus on the last two items there. The idea of an angle is a space between those two rays, and then more so the representation of a term. One of the common misconceptions our students have with angles are the arm length. Does that matter when you're actually measuring those angles? So we want to make sure that when we are teaching angles, that we are showing different representations of where the lengths of the rays or arms are different.
Probably why it was important in part 1 that they're actually creating all these physical models of the angles with the angle eggs or with toothpicks or anything that they can create and open them, right?
Yep, to see definitely that the length of the rays do not matter.
So before we get into actually measuring our angles, we want to help make connections for kids. Remember, anytime with math, it's just the world of patterns, and whenever we can connect something they understand to something new, they're going to understand it that much better, maybe even create their own understanding of it. So think about when kids first started to learn how to measure a length or a line segment. Well, how do you measure that? What would you do?
I could perhaps use a ruler, maybe a tape measure, maybe a pencil.
All good tools.
Yeah.
So what are those little things that are on a ruler? What's represented on it?
Those are line segments.
Yeah. Basically, we measure line segments using other shorter line segments, but those segments are standardized. So inches, feet, yards. Maybe they use paper clips. Maybe they use color tiles. Put them along a line. So this is something they did back in primary grades. Before then, they maybe made their own ruler and used that ruler.
I think that's important with building understanding of what that unit is.
Yes, what those numbers are when we say a number as a length. Well, same thing with angles. So when we think about angles, what are we measuring them with? We're just measuring them with other angles. But what are those angles going to look like? Are they going to be big, small? Are there standard angle measures? Are there non-standard?
You know, Joe, that's a really good point. And I never made that connection to measuring with a ruler and non-standard units and understanding what an inch looks like or what a centimeter looks like. But it is the same thing with angles and using non-standard unit measures to understand what an angle is, the size of an angle or its degree.
I think a lot of us, when we got into measuring angles, were just told, oh, a right angle, that means 90 degrees. And we're like, okay, I don't know what a degree is. I don't know if that means hot, cold, or what that has to do with angles, but I'll just run with it, right?
And definitely went straight to protractors.
And straight to the protractor. Well, in part 1, you were tasked with measuring with wedges. We'll just call them wedges. Ideally, we asked you to use your 1/12 fraction circle pieces. You could use some other size fraction circle pieces, or we gave you some paper wedges that you could cut. If you didn't do that, pause right now and go back to that part 1 and do that task. It'd be really important before you keep looking. Another thing you could use is wax paper, patty paper they call it, and you can fold it up into different segments. So you might get that circle divided up into 12ths, or some people use 8ths. It doesn't really matter as long as you got some kind of representation of a wedge.
So the size of the wedge doesn't matter.
Not really, right? Because we could measure length in inches, feet, yards, centimeters, all different lengths, right? I would recommend, though, when you're doing this, and definitely when you did this with students, is you want to have that one single wedge piece. So break out those fraction circles and give them each one wedge.
That makes sense.
Because we want them to see, look, I'm taking this one unit and I'm iterating it. Just like our kindergartners, our first graders, they took that one paper clip and they measured how long their shoe was and they moved the paper clip.
I think doing that also helps students to see that it is actually a circle.
And we're counting how many fit inside, right?
Yep.
Hopefully you did your wedge measuring activity. You had some different angles on your worksheet. You probably saw that this angle here, QRS, I could fit about one of those little wedges in there. Angle HIJ, I could fit about 2 wedges. Angle XYZ, I could fit about 4. And on our straight angle, make sure we're letting students work with straight angles. We want them to see that that is an angle. Oh, I could fit 6 of them there.
This portion of the activity was quite powerful for me. And thinking about what my students would think and the connections that they would be making to using a right angle as a benchmark angle.
Yep.
So if I look
at that in part 1, right? The square angle is a right angle.
Yeah. So I was thinking of how many wedges it would take to fill in a square angle. You could see here it's 3 wedges, which would then support me in thinking that if a right angle is 3 wedges, then I know that a straight angle would be double the right angle, so that therefore would be 6 wedges. It would also support me with, if I know that a right angle is 3 wedges, then an acute angle has to be greater than 3 wedges, correct?
Less than 3.
I'm sorry, less than 3. And then if we're looking at obtuse, I know that that must be greater than 3 wedges.
So hopefully you see kind of where we're going with this whole wedge measuring idea, right? I know when we're talking about degrees, we would say a right angle is 90 degrees. So therefore acute would be less than 90 degrees. But where did that whole idea come from? We can compare that to our work with wedges. And when we're only talking about, if you did a full circle, that's only 12. That's not a lot of wedges for the kids to work with. When we're talking about degrees, there's a lot of degrees in a circle, isn't there?
I think this helps support to build the idea of a degree, though, and their
Absolutely.
understanding of it.
Conceptually, I'm going to understand what I'm talking about. So next, we often will have the kids like, all right, it's getting tedious measuring with this one wedge. There's got to be a better way to do this. You challenge the kids, can you make some kind of tool? And often, more often than not, the kids are going to come up with something where they trace the wedges on paper. You could then give them maybe this circle cutout, half circle cutout. You could give them a full circle. Doesn't really matter.
Would this be more along the lines of the representational? So we've worked with the concrete wedge. Would this definitely be the connection that I'd be making between that and the representation, this particular tool that you're referencing here?
Definitely. And we can even give this tool a name and call it a protractor. So this introduces what a protractor is, how it works. I can see my units on there. You can even have the student's number and think about, well, where do the numbers go? Where does 0 go? Where does 1 go? Does 1 go in the middle of where that wedge is, or does it go at the end of one wedge? So you were talking about a ruler. That's a number line. Really, we have a number line wrapped around the outside of our protractor. Mm-hmm. So do our numbers go within the unit or at the end of a whole unit?
I think introducing it this way is definitely less overwhelming than just handing them a protractor.
And really, they do have a protractor. It's just a different one than we're used to seeing. It's a wedge tractor or something. I don't know, whatever you want to call it. Wedge tool. You can still call it a protractor. Have them then go and measure those same measurements they're doing. Maybe measure angles on paper. Maybe it's angles in the classroom that they're looking for. Use your new tool to go and measure. They should hopefully see that they're getting about the same measurements as just having that wedge. Again, just like kids in kindergarten, first grade, second grade, they made their own ruler. They went and measured it, non-standard units, standard units. We want them doing the same thing with angles.
Something that would be important to point out too is the questions that we ask as teachers for them to make that connection from using the wedge to actually this wedge tool or protractor, if you want to call it.
Definitely. So one of those other understandings of an angle is that of a turn. We looked at that in part 1. We're bringing that back. So think about any of our angles. If you're thinking of it as a turn, as we just start opening our angle more and more and more, if it just keeps going, what's it going to make?
Right. This is a great visual.
You see our little video, just pull your 2 angle legs together, turn them around, they're going to come back around and meet, right? And they made a circle. So kids can even model this with their angle legs, with a pencil tracing around it. And they'll see that they're making a circle.
Yeah.
Well, if we were just so happen to be using as our wedges fraction circles that will fit into a circle, so we can make that nice connection. How many 1/12 wedges are going to fit into a whole circle?
That would be 12 twelfths.
That would be 12 twelfths, right? That would be 12 of them. And look, we can find maybe here's a right angle. As a turn, 3 of those 12ths fit inside that turn, right? So we're bridging the idea of the turn and bridging the space in between. But we don't have to use 1/12 wedges. What if we used a 1/4 wedge?
It definitely would be a lot less wedges.
We probably can't measure as many angles, and we definitely can't measure them very accurately. We could find a right angle, right? Maybe a straight, but that's about it. So if we had a smaller angle, that 1/4 isn't going to really help us. Let me see, even with the 1/10, that might be another wedge that we could use. Students can experiment with using these different size wedges and noticing which ones are more helpful for measuring certain angles. But ultimately, you do want them coming back to that idea of, oh, within a circle, how far is this turning? Well, what if I gave you a wedge that was 1/360th of a circle?
I would need 360 to make a full circle.
So when we normally talk about angle measurement, we talk about the standard unit of measure, which is degrees. So what really is a degree? You're probably catching on to now. A degree is just a 1/360th wedge. It's just a really small wedge. Really? So Emily, I'm giving you this one wedge here. Can you go ahead and measure that angle using
I could, Joe, wedge? But I don't think that's the most efficient and effective way.
Yeah, look, we could just fill in all those tiny little degree wedges, right? Yes. And you can ask students to do that. Give them that little tiny wedge. They're going to get frustrated. But harken back to, oh, hey, remember you made a tool called a protractor with our wedges? You can do the same thing with our degrees. In fact, here is a protractor that has, in this half circle, 180 little degrees on it. And I can just put my angle right over that.
I do think, though, that starting with the larger wedges and then connecting to this smaller wedge, which is a degree, definitely is a nice connection for them to the protractor that we will talk about next time.
Absolutely. And I think a lot of our misconceptions students have with the protractors, just taking this approach that we did in our part 1 video and now this approach, the concrete, the non-standard unit of wedges, to them making their own tools, will really help overcome most of those misconceptions students have.
Joe, that visual you have in the top right corner showing the rotation or the circle is a nice visual. It definitely helps me to see why we call it a 90-degree angle or why we call it an acute angle. It's a nice visual to see how that's in relationship to 360 degrees.
For sure. And we do want to be careful, though degrees are a standard unit that we can measure angles with. Later on in geometry, a lot of our students, you can also measure the turns, angles, using something called radians. And you see that radians are actually like slightly larger wedges than what we're using in our 12s.
Learn something new every day.
A little over 6 radians around a circle. That's about my limits of, I'll go with radians, but.
Deep thoughts with Joe.
So thank you for watching part 2. See, we're making these connections across our CRA islands. It's not that we're going for that abstract. That isn't the whole end all be all. It's the journey along the way, the connections that we can make between the concrete, the representational, and getting into that abstract thinking.
I think it's important too, Joe. Is it okay if I needed to go back to the concrete land if my students are struggling still with the concept of a degree before I introduce the protractor to them?
Yeah, just cut out a whole bunch of those little degrees for them. They can just place them in.
I'll get right on that.
Okay. 2, be sure to look out for part 3 in this measuring angle series.
Have a great day and thanks for being with us.